Hello everyone, my name is James Nicolau in CS 405, the year 2024, and I am presenting the security policy for Green Pace. In an overview, defense in depth is the idea of providing multiple layers of defense methods to create an all-catching web, like a multi-layered spider web, to trap all of its prey, or in our case, security risks. This security policy is to implement this concept via security principles, C and C++ standards, encryption, and AAA policies, and unit testing examples of these standards and policies in effect. This presentation will also cover some of the pitfalls in security policy recommendations on how to remedy them. Our graphic on this slide covers a threats matrix, organizing the standards, should they be ignored, into the level of likeliness and priority of these errors. We want to focus on the likeliness of the threats first, as if there's a common threat to automate or implement a specific policy to mitigate it. Next, we want to focus on the priority level. If it is a greater threat, then we need more focus on that before a more minor threat. Here are the 10 principles of the security policy and the standards that relate to each one. Validating input types is as it sounds, ensuring the right kind of data and the value of the data is appropriate. Compiler warnings are there to help the developers, so it's best to at least refer to them if they arise. Generally, they cover data management, data types, and string correctness, as well as overall proper implementation of the code itself. Architecting and designing for security policies is the idea of creating code that is securely focused to help mitigate security risks in development and further on, like SQL injections. These are standards that promote the security first concept. So keep it simple. Sounds silly maybe, but the simpler something is, that as long as it meets all the criteria of the product, the easier and more efficient it is to manage and develop. Below are standards to help enforce this principle. Utilizing a default deny concept helps prevent security risks by assuming everything as a security risk unless proven otherwise. It keeps everything on lockdown until the proper authorization is received. The standards below are tools to help promote this principle. Adhering to the principle of least privilege is along the same thought process as default deny. Only providing the minimum level of privilege needed to accomplish a task helps keep unauthorized users away from sensitive data. These standards help enforce this principle. So sanitizing data sent from other systems helps keep things safe by removing potential threats, tagging along the seemingly safe data transmissions. Generally, they affect memory or data type vulnerabilities. So practicing defense in depth. The example of the spider web I used earlier is put into application with these standards below. The effective use of quality assurance techniques ensures that the product is up to standards via constant testing and review. These standards are examples of implementing this principle. Adopting a secure coding standard is the key to providing the same results with different products. The more the same things are, the easier they are to develop, test, and fix. These standards support this ideology. So on the right, we have our 10 coding standards listed. These standards help us mitigate vulnerabilities, but in the event one happens, what do we do? It's best to rank them based on what will do the most to the least amount of damage to the product or service. Once the level of damage is identified, what is the actual likelihood something's going to happen? I'm not saying to ignore things that may happen, but they can be focused on later if there's a good chance it may not occur at all. The use of proper testing and development of the code within the product will protect the product from everything on the development side of things and help prevent attacks when the product is released. So here we have the three main encryption policies. First is encryption at rest, or the hardware level and the code level on our end. So full disk encryption for server and databases help provide security at the development level. Encryption in flight is during the transmission of data. How do we keep it safe? Encryption of incoming and outgoing data of all types via SSH, password access, and other safety methods help prevent malicious intent. Finally, encryption in use. Proper identification to ensure that only authorized users are utilizing the product help keeps things safe. A least privilege approach keeps people away from sensitive data above their clearance, and change request approval systems allow for tracking of changes. AAA, or the policies outlined below, are concepts to promote security at a personnel level. So authentication is identifying a user via usually a login or security key and identifies their access level. Authorization is the concept of authenticated users to be given access to whatever level of privilege they require on a least privileged system. Here we can change the level of access as well, from new users to existing users to removing the users. Accounting is basically keeping tabs on everything. Like the idea that everything needs to be accounted for, all actions are monitored to identify potential hazards. So to begin our examples of unit testing, implementing the policies and standards we mentioned before, we have a test to check the capacity of a collection. So a test at empty is a collection empty. And if we add items, does the collection pass checks of greater than or equal to standard amounts? In this test, it does indeed pass as a true test. This test checks if arithmetic can be done within the parameters of a function for more in-depth level coding later down the road. We check that the container is empty, and then divide 5 by 5 to get 1 added to the entry, and ensure that only 1 entry is added. As the name states, we are checking the max size of a collection. We ensure it's empty first, add 11 values, and then check that we indeed have more or equal to the standard testing values, in this case 0, 1, 5, and 10. So here's our first negative test. We are checking for values within a vector, myVector, and adding 10 values, then trying to see what happens if we access outside the 10 values. We are looking for the 20th value, which of course doesn't exist. Should our test work, it should throw an error, or with the assert throw statement, pass the test. Our second negative test, again testing to ensure something fails when it should fail. We want to check if using the popback method removes the value at the end of the collection. We add 5 for testing, try to remove 1, and then check that the collection size should not be the same size as before. Our last test is checking to see if, when increasing the reserve of the collection, or the capacity, increases but the overall size stays the same. So here's our automation summary. The DevSecOps system navigates through the pre-production and production cycles back and forth as needed for monitoring the progress at each phase. This diagram covers all the various phases and what occurs in them. So DevSecOps utilizes security tools throughout the automation process to ensure testing is done all along the development cycle to monitor the health of the product. Parasoft and LoadNinja focus on the development side, where Intruders focuses on post-production and performs penetrating testing like malicious attacks. For our security policy, there are some pros and cons. The pros are providing constant security throughout the entire development cycle and post-development cycle, allowing us to implement earlier and constant testing for continual review of the product meeting standards. This will allow the product to be more secure before production and release instead of testing for all possible errors after. Of course, the cons would include the time and money commitment, and it does take quite a bit of work to schedule and build the system. But overall, the small cost of investment is far cheaper than paying out for damages should a security breach happen. This policy does have a few flaws. Pre-production has no depositories defined, no enforcement for each stage, and the encryption ideology is discussed but never enforced or examples provided. So referring to the recommendations from the last slide, we say that a well-defined repository provides multiple benefits, including version control capabilities, changes tracker, improved collaboration, and provide built-in review tools. A lack of enforcement for each stage may produce confusion, stagnant code, and redundancies. Examples to improve this include automatically deleting data when it exceeds its retention period and blocking users who attempt to access unauthorized data. Encryption is critical to keep data safe. So some methods we could use are triple DES, AES, RSA, Blowfish, and Twofish. This concludes my presentation. Thank you for watching.